In this video, I'm going to practice 4 different problems with you that will prepare you for your upcoming checkpoint quiz to show me individually, can you do this? So I'm going to go through exactly what I expect. The very first thing when you're provided a problem like this is example number 1, you are going to need to identify the period, also known as the period length. So I'm going to take 2 pi. I'm always going to divide it by whatever is directly stuck with the x, which happens to be a 4 pi. I know the pi's, and in your mind you can think cancels out. Really what happens is they are going to be simplified to ones. But I'm left with 2 over 4. 2 over 4 reduces to 1/2. This is the period. What does that mean? It means after 4 steps, 1, 2, 3, and 4, I'm going to be horizontally at a length of 1/2. The second thing I need to do is I need to identify what the x scale is. To identify the x scale, I'm going to take 1/2 and I always divide it by 4. Now don't stress. You'll have a calculator available for you. If you're practicing at home, remember decimals can do and achieve the same thing. So I'm going to take 1/2, putting it in parentheses. I'm going to divide it by 4. If I get a decimal, I'm going to turn it back into a fraction. I did get a decimal. I'm going to turn it into a fraction. And I have an x scale of 1/8. What does that mean? It means that each one of these is 1/8. If you got it incomplete on your homework, it's more than likely that you did not label these. I know it's a pain, but that's part of the process. So I'm going to quickly identify the remaining step 2, 3, 4, 5, all the way out to 8. So I'm going to do this quickly. Here we go. Step 2, so I'm taking 2 times 1/8 and turning it back in. So this is 1/4, 3 times 1/8, and turning it back. This is 3/8. I already know step 4. 5 times 1/8 is 5/8. I know this would be 6/8, which reduces down to 3/4. This is 7/8, and this is 8 over 8, which is 1. I could use the calculator to do every single step there. I'm just going a little bit quicker to make sure we get through this before this class has to leave. So step 1, I need to identify the period. Step 2, the x scale. Step 3, I'm going to label these. Now with the sign, turn to your partner. If we think of this as land formations, what are my 2 options? It's either going to be hill, valley, or valley, hill. That's the shape that we're going to make. It's one of these 2 options whenever you're working with the sign. So I'm going to come off to the side, and I'm going to make a little input-output chart. This is my input. This is my output. Okay? So 0 through 4. There's 0, 1, 2, 3, and 4. And now I'm going to plug in those inputs. So if I come up above and I plug in 0, 0 times 4 pi is 0. So let's evaluate the sign at 0. I grab my unit circle. I find 0. And then it would be really common for students to be like, well, do they want me to choose 1 or do they want me to choose 0? We have to see what function they're asking for. They're asking for the sine function. So what is the sine at 0? The sine is the second number, so the sine is 0. So this portion is 0. What's 0 times 5? 0. So I'm going to come here and I'm going to graph 0, 0. Now let's do 1/8. So I'm going to come off to the side and show my work here. Y equals 5 sine of 4 pi times 1/8. And I want to simplify this. Well, how do I simplify that? Okay, 4 times 1 is 4, and there's a pi. 1 times 8 is 8, and now I need to reduce 4 over 8. If you don't feel confident, you either grab decimals at home or grab a calculator. 4 divided by 8, hit math fraction, enter, enter. That means this portion is 1 pi over 2. So I want to go to 1 pi over 2, and I want to evaluate the sign. That's what this is asking me to do. Let's locate 1 pi over 2. Here's 1 pi over 2. What is the sign? The sign is 1. So this portion is 1. 1 times 5 is 5. So I get to come up to 5. Let's do that. 1, 2, 3, 4, 5. Leslie, do you believe, based on this information, Leslie, that this graph is going to represent a hill and then a valley, or a valley then a hill? How did you say that? Why? Because we went up first, right? We went up first. So now this is where I get lazy. So I go up first and then back down. 1, 2, 3, 4, 5. And I go down to 5 and back. And if you're like, Miss Bradley, I'm just not sure I'm going to remember that. Guess what? Then you don't have to be lazy. You could plug in 1/4. And then you're going to simplify. And I'll tell you, you're going to end up with 1 pi. Okay, then you go to your pi, you evaluate the sign is 0. 0 times 5 is 0. And you'd see each one of these if you went through. Now, after you have one cycle, what do we do next? Well, after one cycle, we just continue it. So I'm going up here, back down, into here. Whoops, I got to be a little more exact there. And we're going to continue this back down. So it's giving this wave curve. Giving this wave curve. And that is our first example where I have sketched the graph of y equals sine 4x pi. We're going to jump now. We're not working with sine. Now we're looking at cosine, but we're going to do the same thing. So the first thing is I want to identify what is going to be the period. So I write down period or the period length, and I'm always going to take 2 pi and divide by whatever's directly in front of the x. It's attached to the x, which happens to be a 3 pi. Now, the pi on top and the pi on the bottom are going to simplify to 1. In your mind, you may think that they're just going to be eliminated. And I'm left with 2/3. That means after 4 steps, 1, 2, 3, 4, I am at 2/3. There is no pi there. We've eliminated the pi's. They've simplified themselves into ones. They're no longer a part of this. We next need to figure out what is the x scale. So to figure out the x scale, I take this 2/3, I'm going to put it in parentheses, and I always divide it by 4. That's going to be the distance from one step to the next. I'm going to use a calculator. That 2/3 is going to stay in parentheses, and I'm going to divide by 4. If I get a decimal, I'll turn it back into a fraction. I did. Okay, I get 1/6. So this is 1/6. How do I figure out these other numbers on the bottom? Okay, as a reminder, this is going to be step 2. I take it times the x scale, and then I turn it back into a fraction. I am not attaching a pi symbol. The pi, again, has been eliminated. Step 3 times 1/6, and I'm just going to go through this quickly. I've done step 4. Let's go on to step 5. We can see step 5 is going to be 5/6. Step 6 is going to be 6/6, which is 1. Then I'll have 7/6, and 8/6 reduces to 4/3. So I'm going to quick review. It doesn't matter if it's sine or if it's cosine. My procedures at the beginning are the same. Identify the length of the period. Identify the x scale, or the length of one step. This is horizontal, we're measuring. And then we're going to label these. Now I'm going to make a t-chart. And as a reminder, when we're looking at cosines, which is our newest graph that we are working with trig functions, we have a different shape. It's still a wave curve, but we're either going to see a hill, so it's going to start high, then valley, and then hill, or it's going to start low, valley, hill, valley. Let's check this out. So I have 0, 1/6, 1/3, 1/2, bless you, and 2/3. I'm going to start with 0. 0 times 3 pi. Well, 0 times anything is 0. So this would be 0 when I substitute in a value of 0 for x. So I need to know what is the cosine of 0. Let's figure it out. Here's 0. Cosine is going to be the first value. So at 0, the cosine is 1. That means when I plug in 0, this portion is 1. And 1 times 4 is 4. So let's start out at 4. 1, 2, 3, 4. By the way, look at, I started at a high point. That means this is going to be an example of hill, valley, hill. Let's do 1/6. I'm going to show my work off to the side. Down below, we have a little more space. Y equals 4 cosine of 3 pi, and I want to take it times my 1/6 input. So 3 times 1 is 3 over 6 with the pi. That reduces to 1 pi over 2. And I could use a calculator to reduce that. Well, how does that help? I want to know what is the cosine at 1 pi over 2, or pi over 2, also known as. What is the cosine? Well, here is pi over 2. The cosine is the first number, so it's 0. This is 0. What is 0 times 4? 0. I'm going to do just one more because this is a tough one for many students. Y equals 4 times the cosine of 3 pi. And now I'm going to input in a value of 1/3. So when I simplify this, 3 times 1 is 3 over 3. Okay, that just gives me 1 pi. Let's figure out what is the cosine at pi. Okay, cosine at pi. Here's pi the cosine is -1. So this portion evaluates to -1, but don't forget, you got to multiply it by that outside number. 4 times -1 is -4. That's enough for me to see this pattern. And then this is where your cheating skills come into play. Now, if you didn't feel confident, you could continue to do the 1/2 and the 2/3. But I know that when I plug in 1/2, I'm going to get 0. And when I plug in 2/3, based on the patterns, math is about patterns. And so it's looking like this. Remember, don't make it too sharp. And now we have to consider that pattern as we continue to go to the right for a second. So then it's going to go middle, low, middle, high. And off here to the opposite side. All right, this is an example of graphing y equals 4 cosine of 3 pi x. 3, this is example number 3. We're going to do 4 examples in this video. Now, where I think kids are going to get messed up here is they're going to forget that in front of that x right now is a 1. So it's really like a 1/2 in front of the x. I'm going to start by identifying the period. So the period is going to be 2 pi divided by, well, what's stuck with the x? It's a 1/2. And if you're not comfortable, grab that calculator. I know it's going to give you 4, but if you're not comfortable, let's take 2 divided by 1/2, and then we need to attach, oh, I forgot the divide symbol, and then we need to attach the pi afterwards. We can see we get an answer of 4. So the period is 4 pi. Now, what is the x scale? The x scale is 4 pi, and we're always dividing by 4. 1, 2, 3, 4. The length of one cycle, called the period, or period length, is 4 pi. And the x scale is the distance from one of these hash marks to the next horizontally. That's 1 pi. So this is really easy to label. 2 pi, 3 pi, 4, 5 pi. And now let's go. So we've done 2 cycles to the right. Let's do a 1 cycle to the left. What's next? Okay, well, now I'm going to put in the inputs 0, 1 pi, 2 pi, 3 pi, and 4 pi. So it's 0 step, 1 step, 2 step, 3 step, and 4 step. As a quick reminder, turn to somebody next to you. When you think sine, what is the formations we think of in our head? Go, you can look in your notes. What formations do we make? We are either going to make a hill-valley or we're going to make a valley-hill. And knowing that fact, it's one of these. Knowing that fact is going to allow us to cheat and still be accurate. Let's get started. When I plug in 0, 1/2 times 0 is 0. Let's evaluate the sine at 0. So I'm grabbing my paper. Here's 0. Sine is the second number, so I get 0. This is 0, and 0 times -2 is 0. All right, now let's slow it down. Now I want to input in a 1 pi for x. So y equals -2 sine of 1/2 times 1 pi. Well, 1 times 1/2 is just 1/2. So this is 1/2 pi. Let's find 1/2 pi, also known as pi over 2, and let's evaluate the sine at that place on the unit circle. Here's 1 pi over 2. The sine is the second number. It is 1. So this portion evaluates to 1. I need to take it times the -2. 1 times -2 is -2. Leslie, can you help me out? Can you tell me right now, based on this information, what is going to be the formation of one cycle here? And why did you choose Valley Hill? You're correct. Went down first. So it comes back up. Then we're going to go up 2 and back here. So it's going to be a valley and then a hill. So I can put this in. This is 0, 2, 0. And I'm just going to continue the pattern here. I've done 2 cycles to the right, 1 cycle to the left. We are going on to our very last example. And if you're in class with me, I want you to get a head start on this tough one. Here it is right here. Again, this entire video is preparing you for the hardest questions on your quiz on Monday. So here it is. If you are with me, please write this down. We are going to evaluate the function y equals negative 1/2 cosine of 3x. And you're required to take notes right now.
So I have to put on here.
So what I'd like to do right now is I'd like us to first identify what is the period. So period is going to be 2 pi divided by whatever is directly in front of the x, happens to be a 3. So after 4 steps, 1, 2, 3, and 4, I'm at 2 pi over 3. Got it. Now the next step is always to find the x scale. I'm going to take 2 pi divided by 3, and we're always going to divide that by 4. So I'm going to use a calculator. I'm going to omit, or that means I'm going to forget for a second about plugging in the pi symbol. And I'm going to use the calculator as a tool to simplify this. 2/3 divided by 4, it's a fraction. Let's put it back in, is 1/6 pi. What does this even mean? The x scale represents the distance horizontally from one of these hashtags to the next. So 1/6 pi. And then I would use the calculator. And as I use the calculator, I would go, okay, step 2. So step 2 times 1/6. And then turn it back in. And I'm just going to do this a little bit quicker. So I have 1 pi over 3. My third step would be 3 times 1/6. You guys get the idea of this. Turning it back in would be 1/2 pi. I'll tell you, this is going to be 5/6 pi. This is 1 pi. This is 7 pi over 6. And 4 pi over 3. And I just know that by quickly being able to simplify, but I could definitely use the calculator again for each steps. For instance, the fifth step would be 5 times 1/6, and then turning it back into a fraction. You can see how I get that. Okay, turn to the person next to you as I'm writing. How do I know based on the function, its cosine, what shapes will I have? I'm going to abbreviate here. It's either going to be a hill, valley, hill, or it's going to be a valley, hill, valley. It's going to be one of those two options. So let's make ourselves an input-output. We can finish this up in the next minute or two. Here we go. This is my input, and this is my output. Are you ready? Here we go. All right, input, 0, step 1, 1/6 pi, 1/3 pi, 1/2 pi, and 2/3 pi. I'm only going to have to do the first two. Let's start with 0. If I substitute in 0, 3 times 0 is 0. Let's find the cosine at 0. Here's 0. My cosine is the first number, and I get an answer of 1. So this evaluates to 1. Now 1 times negative 1/2 is negative 1/2. So I'm going to go drop down, and I have to label this. This is negative 1/2. Miguel, does that tell me that this is going to be a hill, valley, hill, or a valley, hill, valley? Valley, hill, valley. Perfect. Why did you get that? Perfect. Now I get to be lazy. Watch. So if that's the truth, then here's 0. Then I go hill, valley, hill. That's going to be one cycle. And if you're like, Miss Bradley, I just really like to know for sure, then you plug each of those in, you do the work, and you'll find the exact same things. So this is going to be 0, 1/2, 0, and negative 1/2. And I'm just going to continue the cycle. Please be as accurate as possible while you sketch this. And as a reminder really quickly, we could look at this and we could say like, hey, looking at the graph of this function, what is the output of this function at 1/2 pi? And we would say 0. What is the output of this function at 2 pi over 3? And we'd say negative 1/2.